Hello, fellow teachers. I'd like to share with you, if you don't already know, this amazing website called Cult of Pedagogy. It's written and produced by Jennifer Gonzalez, and I find it really inspiring as a true teacher nerd. Um, and I'd like to share a particular post with you, um, which deals with traditional versus backward planning. She writes, traditional lesson design. For many years, teachers have been planning lessons in units of instruction like this. Step 1. Identify a topic or chunk of content that needs to be covered. Step 2. Plan a sequence of lessons to teach that content. Step 3. Create an assessment to measure the learning that should have taken place in those lessons. Notice that in this approach, the assessment is created after the lessons are planned. Sometimes it isn't created until most of those lessons have already taken place. The assessment is kind of an afterthought, a check to see if students were paying attention to the stuff we taught them. For most of my teaching career, this is how I planned. It's presumably how most of my colleagues planned. I believe it's still how many teachers plan. So what's wrong with it? Well, when we plan this way, we're more likely to include content and activities that have questionable value. When teaching the American Revolution, for example, if our goal is just to teach about the American Revolution, we can throw in anything that has any relation to that topic. A coloring page of the Boston Tea Party, a colonial flag craft project, or a worksheet where students unscramble words like Minuteman, Independence, and Hancock. This random approach creates two problems. The first and most important problem is a lack of durable, transferable learning. One reason so many of us don't remember much of what we learned in school is that we learned it through this haphazard, topic-driven approach. These random activities are taking up precious time that could be spent on much more valuable stuff. The other is poor student engagement. Our students know when they're being asked to do something pointless. If they don't see the relevance of what they're learning or a direct line between the content of your course and a desirable outcome, they'll tune it out. Sure, many students will do what you ask anyway because they want good grades and the benefits that come from them, but they're not learning. If you don't believe me, ask them. Backward design. In their book, Understanding by Design, which was originally published in 1998, Grant Wiggins and Jay McTighe introduced us to backward design, an approach to instructional planning that starts with the end goal, then works backward from there. The full version of Wiggins and McTighe's original approach is pretty complex and can be time-consuming to implement. If you're ready for that, I recommend digging into their book. For now, though, I'm just going to share the most basic version of backward design. Here are the steps. Step 1. Identify what students should know and be able to do by the end of the learning cycle. Step 2. Create an assessment to measure that learning. Step 3. Plan a sequence of lessons that will prepare students to successfully complete the assessment. The difference in order is significant. Plan the assessment first, then plan only lessons that will contribute to student success on that assessment. I was first introduced to this concept in my 6th year of teaching, and the genius of it completely blew me away. I used it when planning my next unit. I experienced the biggest spike in student success I'd ever seen. On top of that, I was actually excited about teaching the lessons I had planned. For the first time, it felt like none of my class was wasted. Everything actually mattered. There was something a lot more satisfying about doing things this way. Let's take a look at an example to illustrate the difference between a unit planned the traditional topic-driven way and the same unit planned with backward design. Before and after, the lunar cycle. The before, where the final product is a test. At some point in their school careers, students study the phases of the moon. One pretty typical way to teach this is as follows. A lecture or video about the phases of the moon, followed by a worksheet to label the phases. An interactive activity like scraping the filling out of Oreos to represent the lunar phases. Following a teacher's sample, creating a physical model of the moon phases using something like styrofoam balls. And then a unit test that requires labeling the phases of the moon from memory and answering multiple choice questions about the lunar cycle, eclipses, and seasons. In many classrooms, teachers also have students track the appearance of the moon over the course of a month, so that might be added as well. Following this plan, a teacher would feel pretty satisfied that they covered the topic of moon phases. But if we look at the next generation science standards, the standard relating to moon phases says that grade 6 to 8 students will develop and use a model of the Earth-Sun-Moon system to describe the cyclic patterns of lunar phases, eclipses of the sun and moon, and seasons. Note the language here. Students are meant to develop a model, then use it to describe these patterns. But in the plan above, students merely copied a model from memory. And they didn't use it to describe anything, even if the model required some written captioning to explain what was going on, because the model was a copy. It can't be safely said that students were really the ones describing the system. Then there's the test. If we assume that a large portion of a student's grade is based on the test, then students are not being measured on their achievement of that standard. The standard does not require students to memorize the phases of the moon, nor does it ask them to demonstrate knowledge of how the whole system works. The standard wants students to develop a model and use it to describe the system. It would be easy to blow off this distinction, to say, bah, same difference. The test asks students a lot of questions that would show an understanding of these concepts, so we're covered, but not really. Asking a person to develop a model is a much higher order task than asking them to copy a model. Describing systems and patterns is way more challenging than selecting the correct description. Developing models and explaining things is the work of real scientists. They notice phenomena, study it, then figure out how to represent those phenomena in order to make it clear to other people. To say, look at this, it's interesting, and it explains why things are the way they are. And that's exactly what the National Science Standard authors had in mind. Any education that focuses predominantly on the detailed products of scientific labor, the facts of science, without developing an understanding of how those facts were established, or that ignores the many important applications of science in the real world, misrepresents science and marginalizes the importance of engineering. In other words, a superior education will teach students to think and practice like scientists. If we don't plan learning experiences that make that possible, we're giving them a subpar education. Okay, the after, where the final product is a model and a presentation. So if we redo this unit plan with backward design, we'll need to start by developing an assessment that would measure success with that standard. That means the assessment would not be a test where students merely label the moon phases, but a student-developed model of the moon phases, along with some kind of presentation where students use that model to explain lunar phases, eclipses, and seasons. When designing this final assessment, it's essential that the teacher crafts a rubric that clearly outlines specific, high standards for both the model and presentation. The rubric should list criteria for the accuracy and functionality of the model, plus the quality of the presentation itself. Here's an example of what that might look like. Okay, so we see a rubric with model accuracy, functionality, presentation, aesthetics. With a good rubric in place, we then work backwards to determine what lessons students need to do excellent work on the final assessment. So there's direct instruction. Memorization is not the goal. Okay. Active processing, that students get a chance to work with a model. They need practice in presenting the model, and then they develop their own models, and then they present the models. With this after version, every lesson is designed to prepare students to give excellent presentations at the end. The whole time, they are using the lunar cycle of vocabulary, correcting each other's misconceptions, and just like scientists, thinking about how to explain concepts to other people. Okay, so we've looked very closely at one small unit for a middle school science class. Now, take the same process and apply it to the things you teach. 1. What exactly do the standards require? Do they ask students to memorize and identify facts? Or do they ask them to describe, explain, analyze, create? It's probably the latter. 2. If it's the latter, how closely do your assessments measure those standards? Do they actually require students to do the describing, explaining, analyzing, or creating, which would likely require them to write, present, or create some product? Or do they merely ask them to recognize when someone else does it in the form of an answer on a multiple choice test? Do you need to adjust your assessments so they more closely align with the standards? If you do, the next step is to rework the lessons that lead up to that assessment. Does every lesson contribute to student success on that assessment? Could some of your lessons be omitted because they don't connect directly to the assessment? Are you missing anything? For example, if your assessment requires students to write in academic language and support their ideas with evidence, you should include some lessons that give students practice with that kind of writing. Finally, will the assessment be weighted heavily in your gradebook? It should be. The lessons and activities leading up to the final assessment are there to give students exposure to the knowledge and practice with the skills necessary to perform on that final assessment. Ideally, they should receive no grades at all on those activities. If you absolutely must assign some points, be sure the final assessment is worth a heck of a lot more than those smaller tasks. Like I did, you probably also have some favorite lessons and activities. Some of these might turn out to be not just fun to teach, but also solid in terms of equipping students with knowledge and skills that will last. If it turns out that those favorite lessons don't really align with any standards, you might be able to revise them so they do. Or you might keep them for other reasons. Not every minute of class time has to be spent on standards-based instruction. Some activities have value because they help us get to know each other better, they help students develop social emotional skills, or they simply offer a bit of fun. But if a lesson doesn't do any of these things, if it's disguised as learning but is doing little more than keeping students busy, it's time for it to go. Using a process like backward design helps us get better at making these decisions. By making this approach part of our regular practice, we'll be able to look back on a day, a week, or a year of teaching and say with a lot more certainty than when they were under our care, our students learned.